All right, here we are with the exercises. Again, these first exercises are ones that you should really do on your own. After that, exercises 4 and 5 are pretty tricky, and if you need some help there, that's okay. And if you're stuck on exercise 2 here, that's okay. At least watch me do the first one first to give you a hint, and try B on your own. So for the first one, we want to get y equals something like f of g of t, and the this should be x here. I have to say on the inside because the variable here is x, so we should have an expression with x. Anyways, the g of t should be the thing that gets done to x first, the result of which gets plugged into the other function f. So the thing that gets done first here looks to me like x squared plus 1. So I'm going to say g of x is x squared plus 1, and f of t, the outer function, could just be the square root of t. And those are two simpler functions, and if you want to compose them to check, let's work this out here. F of g of x here is going to be f of x squared plus 1. That's the output of g of x. And we're going to make that be the input into the square root function here. That's going to be the square root of x squared plus 1. And that works. Okay. So this one, if you haven't done this one yet, now's the time to pause it and do it. But anyway, here's what I would do. I would say if we want to make y equal to f of g of x, I would make the g of x be x minus 2 might work. And then the f of t function could be 5 times t to the power 3. That would work. And there's some other answers that would also work here that I'm going to write out here while it's paused so you don't have to sit through them. I'll show you them in a moment. So for the part A here, you could have just said g of x is just x squared, and then when you plug in that output into t here, that will also work just fine. And here's another one maybe you've been thinking about, is what if g of x is just the whole function, and then when you plug that into t, into the input of the other function, you're just going to get the square root of x squared plus 1, which works, I guess. So that is correct, but it also deserves an eye roll emoji there. For the other one over here, part B, you can say x minus 2 cubed is the g of x part, and the f of t is just 5 times t. That would also work, because if you replace this t with x minus 2 cubed, you'll get the original function. So that will work. Or another answer is you could just say, what if g of x is just x itself? And then if you replace t with just that x, that gives you the original function too. So that works, but isn't really very interesting. Okay, so exercise 3. Here's another one you should definitely do. This is a great thing to get practice with. I'll show you the answer for A right now. So we're going to do f of g of t. And g of t here is 2t plus 1. So we're doing f of that. And what does this say to do to its input? We're going to replace the t with 2t plus 1 and square that. So this is going to be 3 times 2t plus 1 squared. So that is f of g of t. With this one, this is the other way around. So let's see. I'm going to get rid of this highlight thing here. So now, this time, the f of t is the input. and f of t is all of 3t squared. That's what we're going to replace the t with in g here. Is just the t is going to become 3t squared. So in other words, we're doing g of 3t squared, replacing f of t with its formula. And now, what is g of that? It's 2 times that plus 1. And you could simplify this as 6t squared plus 1 is a good idea. So that sounds good. This other one I should have mentioned is you might want to FOIL this out and multiply everything by 3. If you do, that should turn into, I think I can do this in my head, 12t squared plus 12t plus 3, I believe. That is also perfectly good. But so is this. Okay, now f of t. This is a little weird. So this time, I'm going to replace the f of t on the inside here. This part, just the f of t, that is the same as 3t squared. So I'm going to write this as f of 3t squared. And what does f do with its input? We're going to, it says it takes the input. Instead of t now, we have 3t squared. So we're going to do 3t squared squared, and then that multiplied by 3. So we're replacing the inside here with 3t squared. And 3t squared squared is going to give you 9t to the 4th. And if you do 3 times 9t to the 4th, that's the same as 27t to the 4th power. Okay, and what about g of t? Okay, well, the g of t on the inside, right there, that is going to be 2t plus 1. And now what does g of t do? It takes its input and multiplies it by 2 and adds 1. So I'm going to replace this t with 2t plus 1. We're going to multiply that by 2 and add 1. So this part is the g of t on the inside. The g on the outside here is multiply that by 2 and add 1. And when you distribute the 2 in there and combine like terms, this should work out to, let's see, 4t plus 3. All right, so that's that. Now, exercise 4 is pretty weird here. Let's try to read what this is asking for carefully, because it's kind of a weird question. We want to write this function here, this y, in the form y equals k times h of x to the power p for some constants k and p. So k and p are going to be numbers. And some function h of x. So we got to figure out what the function h of x is and what the numbers k and p are that make this work. So the first thing I notice about this form here that we're trying to get this into, I've got this thing I want to make this y look like this. And the first thing I notice is that it doesn't have a fraction in it. I'm trying to squeeze this foot into a shoe that maybe doesn't quite fit right now, because right now this does not have a fraction in it, but this one does. So what you can do is you can say, oh wait, this has divided by something to the power 4 in the denominator. That is the same thing as if you write it with a negative exponent, 1 minus x cubed, that quantity all to the power negative 4. That's what a negative exponent, negative 4, does, is it moves that to the bottom of the fraction. Okay, so now, wait, this looks like we have a number times something to a power, which is a number. So what's the h of x function? That would just be 1 minus x cubed. Okay, so we can say that, yeah, this is actually it. This works. The k is just going to be 17. The p is -4. And the function on the inside is h of x equals 1 minus x cubed. And that now works. That is now answering the question. We have this function written in the form a number times a function h of x to a power. Okay, if you understood that, let's try to give b a shot on your own. I'm going to wait for a moment while you have a chance to pause it and work on this on your own. Okay, let's try to work on this together now. If you can check your answer now, or if you're still stuck, that's okay. So right now, the form we're trying to get it into does not have a square root. But can you write a square root as a power? Sure, that would be to the power 1/2. It's just like there's a 2 here. So we can think of this as the square root of x plus 1 to the power 1/2. That's the same thing as the square root of that. So, all right, but it also is written as divided by 23, but we want to write that as multiplied by something. Well, there's a trick to that, is you can write this as 1/23 multiplied by the square root of x plus 1 to the 1/2. And multiplying by 1/23 is the same as dividing by 23. So this is now in the form we want. We've got our h, we've got our k, or sorry, the 1/23 is the k, the 1/2 is the p, and this is the h of x function. So I'll write that out here. Okay, now exercise 5 is pretty tricky, but it's important to get practice with this kind of thing to develop a good understanding of graphs of functions, which is really a key idea of this class. So if you haven't tried it on your own, or if you just got stuck and got scared, at least watch me do A and B, and if you understand that explanation, then try to do C, D, E, and F on your own. This is something where it's really important to do it on your own. And the nice thing about these videos is if you don't understand me explaining A and B the first time, you can always rewind it. That's an important thing about these videos, is if you miss something, you can always go back and watch it again without however much time you have to watch it. Okay, so starting with A. The first thing I want to do is see what is g of -1. So to know what g of -1 is, we have to look at the graph of g here. So on this graph of g, we want to see where is the point where x is -1, because the number -1 is in place of x here. So, well, here's where x is -2. -1 is right here, and that point on the graph is this one here. And what is the y coordinate there? that looks like that y-coordinate is -1 also. So g of -1 is -1. So I'm going to rewrite this as f of -1. And then once you have that, you can then look at the graph of f. So now we know what the input is. The input is the x-coordinate on the graph, and the x-coordinate on the graph here should be -1, and that -1 is right here. And now, what is the point on the graph with the x-coordinate? It's up here. And what is the y-coordinate there? It looks like 2. So that means f of -1 is 2. And that is the answer to that. I can draw a better box than that. There we go. Now g of f of 2. So first thing I'm going to do is I'm going to find f of 2. That's as a number. So I'm going to look at the graph of f and say instead of x, the input is 2 specifically. So x equals 2 is right here. The point on the graph with that x-coordinate is this point right here. So we're going to see what is the y-coordinate there. The y-coordinate is the output on this graph. And the y-coordinate right here is 1. So that means f of 2 is 1. And so that leaves us with finding g of 1. So on the graph here, we're going to see where is the point on the graph where x is 1. And that's right here's the x-coordinate. The point on the graph is this one right here. So x is -1, the x is +1, and the y here is also 1. So because of this point, g of 1 is 1. Okay, now now's a good place to pause it and try the rest of these if you haven't yet, or if you need to go back and review my explanation again, that's okay. So let's start with f of g of -2. Alright, first we got to find g of -2, because we're going to that as a number, because then we're going to do f of that. So to find g of -2, we're replacing this x with -2 and seeing where is the point on the graph with the x-coordinate. It's right here. So what is g of that? It's the y-coordinate here, which is also -2. So g of -2 is -2. It's kind of a coincidence that g of x is equal to x at these 3 points we've looked at so far. But it's not true everywhere, or otherwise it would just be this straight line that went straight through. Anyways, so we're finding f of -2 now. So here's the graph of f of x. We find the point where x is -2. The y-coordinate at that point is the output, is -1. So that means f of -2 is -1. All right, let's try g of f of 0. Starting with f of 0 here, when you replace the x with 0, there's the point here where x is 0. And what is the y-coordinate there? It's actually also equal to 0. So because of this point here, f of 0 is just going to be equal to 0. Okay, and then g of 0 is up here. It's going to be the y-coordinate at the point where x is 0, which is 2. So the answer is 2. All right, now let's do f of 1. So here's the point on the x-axis where x is 1. The point on the graph that has that x-coordinate is right here. The y-coordinate there is -2. So f of 1 is negative 2. And then, what's f of negative 2? We actually did that here with this last one. It's negative 1, which you can get from looking where x is negative 2, the y coordinate there is negative 1. All right, how about g of g of g of 1? All right, so first starting with g of 1, that is going to be equal to 1. So that innermost g there is g of 1 is 1. And then g of 1 again is going to be 1 again. And then what is g of 1? That's still 1. So that is a weird kind of example where this function, at least for these points that are on this straight line here, gives you the same output as the input. This straight line that I drew, by the way, is a graph of y equals x. But that's not true for all these other points. All right, so yeah, that's a tricky example, but I think it's a good one for understanding how graphs of functions work. All right, so good luck with the quiz, and just want to remind everybody to get started on the homework as soon as you can after you watch the video and take the quiz, so it's fresh in your head. You'll do a lot better on that homework assignment and get more out of it, and be more prepared for what we do in the next section, because the next section is going to rely a lot on this section. Inverses are kind of made up of function composition. So the sooner you do this homework, the better off you'll be. Have a good day.